Google's quantum AI scanned 3-eye atlas images, and the results are nothing short of terrifying.
What if an interstellar object whirling through our solar system is actually a nuclear-powered spacecraft sent by aliens to test how humans respond?
What if I told you that quantum computers are now powerful enough to simulate mysterious objects from beyond our solar system? Just months after the discovery of 3I/ATLAS, the third interstellar visitor to grace our cosmic neighborhood, latest quantum AI systems have been crunching mind-bending calculations that are leaving astronomers absolutely speechless. Make sure you watch closely, because what the AI uncovered might completely rewrite how we understand our place in the universe. The alien visitor that changed everything. It's July 1st, 2025, and astronomers at the Atlas station in Chile are staring at their screens in complete disbelief. They've just spotted something extraordinary racing through space at a staggering 137,000 miles per hour. This isn't your typical space rock. This is 3I/ATLAS, an interstellar comet that has traveled billions of miles from another star system to visit ours. But here's where things get absolutely wild. Unlike any comet we've seen before, 3I/ATLAS has been displaying some seriously puzzling behavior. Just days ago, renowned Harvard physicist Avi Loeb made a shocking observation. This mysterious visitor is literally changing colors before our eyes, shifting from its original reddish hue to an eerie green glow. Now, you might be thinking, okay, comets change colors all the time as they heat up near the sun. But hold on, because what we're witnessing with 3I/ATLAS is completely different. The rate of transformation, the specific spectral changes, and the timing of these shifts have scientists scratching their heads and asking uncomfortable questions. Here's what makes this comet truly mind-boggling. It's not following the usual playbook. Most comets from our own solar system behave predictably as they approach the sun. They develop tails, they outgaze, they follow well-understood physics. But 3I/ATLAS? It's playing by its own rules, almost as if it's responding to forces we don't fully understand yet. The most chilling part? Dr. Loeb has developed a new scale from 0 to 10 to determine whether objects like 3I/ATLAS could be technological rather than natural. And the numbers? They're not as comforting as you might hope. When quantum meets the cosmos. Now, here's where our story takes a jaw-dropping turn into the realm of quantum computing. While astronomers were busy tracking 3I/ATLAS with traditional telescopes, something revolutionary was happening behind the scenes in Google's quantum labs. Google's quantum AI division has been making absolutely incredible breakthroughs lately. Their latest quantum chip, Willow, represents a quantum leap in computational power that most people can't even comprehend. We're talking about processing capabilities that make our most powerful supercomputers look like pocket calculators. But what does this have to do with our mysterious interstellar visitor? Everything. Sources close to quantum research facilities are buzzing about simulations that have been running around the clock, crunching astronomical data with unprecedented precision. These aren't your ordinary computer models. They're quantum simulations that can process millions of variables simultaneously, modeling complex gravitational interactions, chemical compositions, and even theoretical propulsion mechanisms that would be impossible to calculate with classical computers. The timing is absolutely fascinating. Just as 3I/ATLAS reaches its closest approach to our Sun, quantum AI systems have reportedly been tasked with creating the most detailed simulation ever attempted of an interstellar object. The computational requirements are so massive that they're utilizing hybrid quantum classical platforms combined with NVIDIA's EOS supercomputer, technology that was considered science fiction just a few years ago. What's really got the scientific community buzzing are whispers about the simulation results. While official reports remain classified, leaked information suggests that the quantum models are revealing patterns in three I/ATLASs, behavior that simply don't match natural comet activity. The simulation results that shocked everyone. Here's where things get absolutely spine-tingling. Multiple sources within the quantum computing community are reporting that something unprecedented happened during the three I/ATLAS simulations. The quantum AI models the comet's trajectory and apparently discovered anomalies that have traditional astronomers completely stumped. We're talking about gravitational signatures that don't align with the object's supposed mass, thermal emissions that defy conventional understanding, and trajectory adjustments that seem almost deliberate. One particularly mind-blowing aspect involves the comet's recent color change. When quantum algorithms processed the spectral data from three I/ATLAS's transformation from red to green, the results were so unexpected that researchers reportedly had to run the simulation multiple times just to verify they weren't dealing with a computational error. The quantum simulations apparently revealed that the specific wavelengths and timing of this color shift follow patterns that are mathematically improbable for natural processes. It's as if 3I/ATLAS is responding to solar radiation in ways that suggest internal mechanisms we've never encountered before. But perhaps the most shocking discovery involves the comet's growing tail. Recent images from the Gemini South Telescope show that 3I/ATLAS is developing one of the most unusually structured tails ever observed. The quantum AI, when tasked with modeling this tail formation, reportedly identified geometric patterns and particle distributions that don't match any known comet behavior. Industry insiders are whispering about simulation results that show the tail is displaying what can only be described as organized structures. The quantum algorithms detected repeating patterns and systematic variations that suggest something far more complex than simple ice sublimation. What the experts are really saying. The scientific community's reaction to these quantum simulation results has been nothing short of explosive. While most researchers are maintaining official silence, private conversations paint a very different picture. Dr. Avi Loeb, who's never been one to shy away from controversial theories, has been particularly vocal about the implications. His recent statements about 3I/ATLAS potentially harboring technological components aren't just wild speculation, they're informed by data that's becoming harder and harder to explain through conventional means. What's really got experts on edge is the quantum AI's predictive capabilities. These systems aren't just analyzing current data, they're projecting future behavior based on quantum mechanical principles that operate at scales we're only beginning to understand. And according to several leaked reports, the predictions for 3I/ATLAS's continued journey through our solar system are unsettling. The quantum simulations apparently suggest that as 3I/ATLAS continues its approach, we might witness even more dramatic changes. The AI models are indicating possible structural modifications, trajectory adjustments, and emission patterns that would be impossible for a natural object to produce. Perhaps most intriguingly, some sources claim that the quantum AI has identified what appear to be communication patterns within the comet's emissions. While this sounds like something straight out of science fiction, remember that we're dealing with computational systems that can process information in ways that human brains simply cannot comprehend. The fact that Google's quantum AI division has partnered with NVIDIA to create hybrid quantum classical computing platforms specifically for these types of simulations suggests that we're dealing with computational challenges that require the absolute cutting edge of technology. The bigger picture and what it means. Let's step back and look at the absolutely staggering implications of what we're discussing here. We have an interstellar object displaying unprecedented behavior, quantum AI systems revealing patterns that challenge our understanding of physics, and a scientific establishment that's clearly struggling to make sense of it all. The convergence of quantum computing and astronomy is opening doors to discoveries that were literally impossible just a few years ago. These quantum simulations can model interactions at the subatomic level while simultaneously tracking massive gravitational fields. It's like having a microscope and telescope working together in ways that defy conventional logic. But here's what's really keeping researchers up at night. If quantum AI can reveal hidden patterns in objects like 3I/ATLAS, what else might we be missing? How many other interstellar visitors have passed through our solar system without us recognizing their true nature? The quantum simulations of 3I/ATLAS represent more than just advanced computation. They're potentially rewriting our understanding of what's possible in the universe. When artificial intelligence systems that operate on quantum principles start identifying patterns that human scientists can't explain, we're essentially letting machines peek behind the curtain of reality itself. Some researchers are quietly suggesting that we might be witnessing the dawn of a new era in space exploration, where quantum AI serves as our guide to understanding phenomena that exist beyond the boundaries of classical physics. The mysteries that remain. Despite all the advanced simulations and quantum computing power, 3I/ATLAS continues to guard its secrets jealously. The more we learn, the more questions arise, and the quantum AI results are raising some pretty uncomfortable possibilities. For instance, why is this particular interstellar object so different from Oumuamua and 2I/Borisov, the previous interstellar visitors? What makes 3I/ATLAS special enough to warrant such intensive quantum simulation efforts? And perhaps most importantly, what are these quantum systems detecting that conventional analysis is missing? The recent discovery that Oumuamua might actually be a fragment of an exopluto, a completely new class of object, has added another layer of complexity to the story. If our first interstellar visitor was something we'd never encountered before, what does that make 3I/ATLAS? The quantum AI simulations are apparently revealing structural complexities within the comet that suggest it's not a simple chunk of ice and rock. Instead, we might be dealing with a composite object containing materials and arrangements that don't match anything in our solar system's inventory. There's also the troubling question of timing. Why are all these interstellar objects arriving now, when we finally have the quantum computing power to properly analyze them? Is this just cosmic coincidence, or is there something more deliberate at work? Some researchers are privately wondering if objects like 3I/ATLAS might actually be probes, not necessarily artificial but perhaps natural phenomena that carry information about the star systems they visited. The quantum simulations might be detecting data patterns embedded within the object's structure, like a cosmic hard drive that's taken billions of years to reach us. The race against time. Here's where our story becomes urgent. 3I/ATLAS isn't sticking around forever. This interstellar visitor is on a hyperbolic trajectory, which means it's going to swing past our sun and then disappear back into the vast emptiness between stars, potentially never to return. The window for quantum analysis is rapidly closing. As the comet approaches its closest point to the Sun, called perihelion, the increased solar radiation is causing dramatic changes that are both revealing and obscuring its true nature. It's like trying to study a snowflake that's melting in your hand. The quantum AI teams are reportedly working around the clock, processing new data as fast as telescopes can collect it. Every hour brings fresh observations of 3I/ATLAS's evolving tail, changing colors, and increasingly complex emission patterns. The quantum simulations are being updated in real time, creating an unprecedented collaborative effort between human astronomers and artificial intelligence. But here's the kicker. Recent reports suggest that 3I/ATLAS might not be following the trajectory that classical physics predicts. The quantum simulations are indicating possible course corrections that would be impossible for a natural object to achieve. If these predictions prove accurate, we might be witnessing something that challenges our fundamental understanding of how objects move through space. The scientific community is facing a race against time to gather as much data as possible before 3I/ATLAS disappears into the cosmic void. Once it's gone, we'll have to wait potentially millions or billions of years for another opportunity to study an interstellar object with such advanced quantum computing capabilities. What happens next? As we look toward the future, the implications of the quantum AI simulations of 3I/ATLAS extend far beyond just one mysterious comet. We're potentially witnessing the birth of a new field of science, quantum astronomy, where artificial intelligence systems help us decode cosmic mysteries that have puzzled humanity for millennia. The hybrid quantum classical platforms that are analyzing 3I/ATLAS represent just the beginning. Future quantum computers will be even more powerful, capable of simulating entire star systems, modeling the formation of galaxies, and perhaps even detecting patterns of intelligence in the cosmos that are currently invisible to us. But the immediate question remains: what will the quantum simulations reveal about 3I/ATLAS in its final weeks within our solar system? Will the AI systems detect evidence of technology, discover new physics, or uncover something even more extraordinary? The scientific community is preparing for multiple scenarios. If 3I/ATLAS turns out to be a natural phenomenon, the quantum simulations will still have revolutionized our understanding of interstellar objects and opened new frontiers in computational astronomy. However, if the quantum AI results continue to suggest something more exotic, whether that's evidence of artificial construction, embedded information systems, or physics beyond our current understanding, we might be on the verge of the most significant discovery in human history. NASA and other space agencies are reportedly developing rapid response protocols for future interstellar visitors, incorporating quantum AI analysis as a standard component of observation strategies. The lessons learned from 3I/ATLAS are already shaping how we'll approach the next cosmic mystery that wanders into our neighborhood. The partnership between quantum computing and astronomy is just getting started, and 3I/ATLAS might be remembered as the object that launched a golden age of AI-assisted space exploration. The quantum breakthrough that made it all possible. The breakthrough behind the 3I/ATLAS simulations lies in Google's new Willow quantum chip, which shattered barriers in computing power that once seemed decades away. This chip can run calculations in minutes that classical supercomputers would never finish, even given the age of the universe. The timing is almost poetic. Willow's debut came just before the interstellar visitor arrived, providing exactly the kind of power needed to simulate something as complex and mysterious as 3I/ATLAS. What makes Willow so extraordinary is its use of quantum entanglement to process multiple realities at once. Instead of running one scenario at a time like classical machines, it can explore millions of possible outcomes simultaneously. This has allowed scientists to model 3I/ATLAS's behavior and also map how it interacts with gravitational fields, electromagnetic forces, and even the subtle quantum fluctuations that ripple through our solar system. It's a leap in cosmic modeling that simply wasn't possible before. The real game changer, though, is the possibility that quantum AI could help us detect hidden messages from beyond. Some researchers believe that if 3I/ATLAS carries information encoded at a quantum level, only technology like Willow could decode it. That means we may be standing at the edge of a new era in astronomy, one where we're finally listening to it in ways we never could before. This breakthrough could redefine how humanity understands the universe itself. Outro. So here we are, standing at the crossroads of quantum computing and cosmic discovery, watching as artificial intelligence systems decode mysteries from beyond our solar system. The quantum AI simulations of 3I/ATLAS have revealed patterns and anomalies that are challenging everything we thought we knew about interstellar objects. Whether 3I/ATLAS turns out to be a natural phenomenon with exotic properties or something even more extraordinary, one thing is certain: we're living through a revolutionary moment where quantum technology is literally expanding our view of the universe. What do you think about these quantum AI discoveries? Could 3I/ATLAS be harboring secrets that will change our understanding of what's possible in the cosmos?